Sahasra Academy. Today we are going to discuss about Newton's laws. Already I have made a video to explain Newton's first law. Today we are going to discuss Newton's second law and third law. Now we will see what is Newton's second law. Generally, most of the people says Newton's second law is F is equal to ma. It is not correct. Newton's second law is F is directly proportional to A. F is directly proportional to A. That means the force applied on the object is directly proportional to its acceleration. Once again see, what is Newton's second law? Newton's second law states that the force applied on the object is directly proportional to acceleration. Is directly proportional to acceleration. Suppose if I replace this proportionality symbol equal, then we have to take m. Here m is mass. Then F is equal to m, and here m is mass, and it is also called proportionality constant. Here the proportionality symbol changes into equal. That is where we have to take a proportionality constant. So m is a proportionality constant. We can call that one as mass. Okay. So this is the definition of Newton's second law. This is the definition of Newton's second law. The force acting on the object is directly proportional to its acceleration. The force acting on the object is directly proportional to acceleration. So from this F is equal to ma. So based on the Newton's second law, we have to explain another one, that is nothing but linear momentum. Linear momentum. So Newton's first law is related to inertia and Newton's second law is related to momentum. Linear momentum. So we can represent momentum with P is equal to mv. P is equal to mv. Then what is momentum? So mass in motion is called momentum. Mass in motion is called momentum. For example, I have some mass. I stand like this. I don't have any momentum because I have only mass. Suppose if I am walking like this, then what happen? I am in motion. I am in motion. My mass in motion. Then when mass is in motion, then it have momentum. Suppose if I am running. So while I am running, I will have both velocity and momentum. Okay. Suppose if I stand like this constantly, I don't have any momentum. Suppose if I run with some velocity, then you can say that I have momentum. Okay. So when mass is in motion, then object have momentum. Otherwise, momentum is the mass into momentum is the product of mass and the velocity. For example, there is a person X. His mass is 20 kgs and he is running with velocity 10 meter per second. Then what is his momentum? 200. What is his momentum? 200. Okay. So momentum is the product of mass and the velocity. And the definition of momentum is when mass in motion. We can say that object has momentum. Okay. So this is the formula for linear momentum. So once again see, what is Newton's second law? The applied force on the object is directly proportional to acceleration. Okay. Ante for example, ఇక్కడ ఆబ్జెక్ట్ అవుతుంది. దీని మీద నేను అప్లై చేసే ఫోర్స్ ను బట్టి ఇది యాక్సలరేట్ అవుతుంది, అంటే మూవ్ అవుతుంది అని దీని అర్థం. ఫర్ ఎగ్జాంపుల్, నేను 10 న్యూటన్స్ ఫోర్స్ అప్లై చేశాను అనుకోండి, యాక్సలరేషన్ ఎంత ఉంటుంది? 10 ఉంటుంది. ఒకవేళ 20 న్యూటన్స్ ఫోర్స్ అప్లై చేశాను అనుకోండి, యాక్సలరేషన్ ఎంత ఉంటుంది? 20 న్యూటన్స్ ఉంటుంది. ఒకవేళ 5 న్యూటన్స్ అప్లై చేస్తే యాక్సలరేషన్ కూడా ఎంత ఉంటుంది? 5 మీటర్ పర్ సెకండ్ స్క్వేర్ ఉంటుంది. అంటే ఎంత ఫోర్స్ అయితే అప్లై చేస్తామో అంత యాక్సలరేషన్ ఉంటుంది. సో ద అప్లైడ్ ఫోర్స్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు యాక్సలరేషన్. Newton's second law states that the applied force is directly proportional to acceleration. From this relation, we can find that, we can derive that F is equal to ma. So force is equal to product of mass into acceleration. Okay, so what is linear momentum? When mass is in motion, we can say that that object is having momentum. So linear momentum P is equal to mv. So momentum P is nothing but product of mass and the velocity. To understand linear momentum clearly, the person X has 20 kgs of mass and he is running with 10 km per hour. Then he has 200 kg per hour momentum. Okay, so this is about linear momentum. Next, Newton third law. Now see Newton third law. What is Newton third law? Newton third law states that for every action there is equal opposite reaction. Here minus represents opposite direction. Okay, for every action there is equal and opposite reaction. So in your textbook Newton's third law definition may be different, but the exact definition and simply meaningfully definition is for every action there is equal and opposite reaction. That is Newton's third law. So examples of Newton's third law is, suppose if you hit the wall with a ball, then the ball will comes back. Hitting the wall with a ball is action and the ball coming back is reaction force. Both actional force and reactional force both are equal. For example, suppose if you hit the ball with 10 newtons force, then the ball also comes back with 10 newtons force. That means action is equal to reaction and this negative symbol is opposite direction. For every action there is equal and opposite reaction. For every action there is equal and opposite reaction. Examples. For example, if you take rocket, the best example for Newton's third law is rocket. Rocket works based on Newton's third law. While launching the rocket will release or exert some gases back downward direction. So this is action and the rocket moves upward direction. This is reaction. So if the gases are coming or exerting fast, then the rocket also moves upward direction fast. So here also there is action force and a reaction force. Both these action and reaction forces are equal. Okay. So once again, Newton's third law is nothing but for every action there is equal and opposite reaction. In exam also you can write directly like this. For every action there is equal and opposite reaction. Okay, so the best example to explain Newton's third law is rocket. While the rocket is launching, it will release and it will exert some gases downward direction. That is action force. And the rocket will move upward direction. That is reaction force. Here both action and reaction forces are equal. So this is the first example. And the second example, in the water while the fish is moving, the fish will push the water back. The fish will push the water back. It is action. And the fish will move forward. The fish will move forward. This is the reaction force. Okay. So here also action is there, reaction is there. So here in order to move front, the fish will push the water back and the fish will move forward. Pushing water back is actional force and the moving fish forward is reaction force. Okay, from this we can say that for every action there is equal and opposite reaction. We have another example, that is bird. When the bird is flying in the sky, the bird will push the air down. The bird will push air down and the bird will move upward direction. So here pushing the air downward direction is an actional force and the bird moving upward direction is reactional force. These are the examples for Newton's third law, and the Newton's third law is for every action there is equal and opposite reaction. These are very, very important, students. Once note down these examples and the statements also note down. Thank you for watching this.